Hi everyone, this is Madan sir here, and I have come up with another topic from alcohol, phenol, and ether, and this is called oxidation of alcohol. So I hope you understand that these days I am doing chemical properties of alcohol and phenol, and in that sequence, this is the next topic. I have to introduce you about that oxidation of alcohol can give a number of other useful products. So that's why this is a very important conversion, and at the same time a very important application of alcohol this is going to be. What are those products that you can get it from oxidation? When you oxidize alcohol, the alcohol converts into either aldehyde, or it converts into either ketones, or it converts into carboxylic acid. So I repeat that. Alcohol on oxidation, depending on the different condition, it can produce aldehyde, ketones, and carboxylic acid. So, considering these three, preparation and conversion, I'll be doing some reaction here, and respected to that, everything coming up, I'll be explaining you, right? So I hope you understand what topic I'm about to take, and this is really going to be important, as a conversion or also as a chemical property. So this is about, this is about, oxidation of alcohol. This is about oxidation of alcohol. Now, like I said, let me see if this is coming in the print. Yeah. So, alcohol of oxidation, let me introduce a bit about oxidation of alcohol under suitable condition can produce aldehyde, ketone, and carboxylic acid. So this is what the introductory part is. So I have to take you through each of the example, and this is really going to be very important for all of you. Let's start with the the basic one. What we do know that an alcohol, like I'm taking this primary alcohol here, this normal alcohol here. This is an alcohol, and there are 3 hydrogen on the carbon. Probably these are something I don't need to repeat. What happened when you reacted with in presence of an oxidizing agent? Please be careful about when you reacted with in presence of a oxidizing agent, and you might have to put some heat also. So this bond, you need to understand that this bond undergo cleavage here, and at the same time another bond, either this one or this one, but this one is most suitable because they are at the maximum distance. So these two bonds undergo cleavage, right? And if they undergo cleavage, what happens? The first thing comes out to be hydrogen. These two hydrogen comes out as a hydrogen molecule, right? And another product, what happened? If you let this bond undergo cleavage, if you want to understand how this bond cleavage, the oxygen become a negatively charged particle and carbon become a positively charged particle. So in order to justify their stability, a double bond is restored here. A double bond is restored here, and this is how you get the aldehyde. So because this reaction is involving elimination of hydrogen, so this reaction is also called dehydrogenation. Right? I hope you understand. The very first thing I tried to make you go. Anyway, so I was saying, because this reaction involves elimination of hydrogen molecule. So this is also called dehydrogenation. So what that means, this reaction has two names, oxidation, but you can also call it dehydrogenation of alcohol, right? So there are two names here. Let's talk about, role of the oxidizing agent and, their specific example. So I have to, take this off so that I can write another equation. In the next equation, I want you to understand that this is a primary alcohol. This is a primary alcohol, right? And in case you use a mild oxidizing agent like CrO3. So a mild oxidizing agent convert this one into aldehyde. So this become an aldehyde. Right? So a mild oxidizing agent like chromic oxide convert the alcohol into aldehyde. So I repeat back here so that you get everything very clear. Alcohol in presence of a mild oxidizing agent converts into aldehyde. But if you further oxidize this, further, I'm just writing very general equation. Further oxidation of aldehyde will produce carboxylic acid. So this is going to be a carboxylic acid. Right? Let me repeat here something very important. If you use a mild oxidizing agent, alcohol first convert into aldehyde, and if you further oxidize it using the same, then it converts into carboxylic acid. Right? Let's take another example. Suppose you are using this particular alcohol, this very same one, and what you are using as oxidizing agent, KMNO4. You are using KMNO4. So probably most of you know this is a strong oxidizing agent. So a strong oxidizing agent directly convert the alcohol into carboxylic acid. So there are two things coming up. One, if you use a mild oxidizing agent, alcohol converts into aldehyde, and then aldehyde, if you further oxidize, converts into carboxylic. But if you use a strong oxidizing agent and provide higher temperature, the alcohol will directly convert into carboxylic acid. So that's the conversion part here. Very, very, each and every reaction is very, very important for conversion. This is something you always been, feeling that this part is missing somewhere. You need to concentrate each and every day, and then all of the reaction going to be quite an easy one. So I hope I have made you very, very clear about this is strong and weak, right? Now let's talk about another, oxidizing agent which has a very important, quality, and what that quality is, let me take you through. If you oxidize an alcohol, maybe I'm taking any one, so it's not like I'm stuck to the same. You can take any, aldehyde, but this is always, you need to understand that this is also primary. This one is also again primary. So a primary alcohol is when oxidized with PCC. PCC is called pyridinium chlorochromate. Let me write because there's something important about it. This is called pyridinium chlorochromate. Right? And this is a, mild oxidizing agent. So this will definitely convert aldehyde. Right? But what is the advantage of using, chromic oxide and, this PCC? That PCC gives better yield. It produces large amount of alcohol during the same reaction. So I'm writing the advantage of PCC here. PCC, it produces or it oxidizes large amount of alcohol into aldehyde. So that is very, very important. So you can use other oxidizing agent, but if you use PCC, this will give you better amount of product. I repeat back, right? So that's how the primary alcohol on oxidation can give you either aldehyde or carboxylic acid. Let's talk about when it will produce ketone, right? So if you have an alcohol like this one, like this one, I'm placing any alkyl group here. So this seems to be second degree alcohol, right? You understand what second degree alcohol is. So if you oxidize a second degree alcohol with any oxidizing agent, the first thing you need aggressive reaction condition. I'm coming to that. Why? Reaction condition, right? So you need an oxidizing agent which should be stronger, and the temperature is also taken higher. Why? Because a secondary alcohol is much more stable than a primary one. So oxidation of secondary alcohol is a bit difficult, right? And to overcome the difficulty, you have to use higher temperature and a stronger oxidizing agent, right? Maybe KMnO4, maybe K2Cr2, 7, HNO3, whatever. And then what happened? This converts into ketone. So this converts into ketone. Mechanism is absolutely same. You have to understand that from there hydrogen will break away, and from one of the alkyl group hydrogen will break away. So this will become double bond, like the earlier one I said you. So the mechanism is absolutely same. So this time you get a 2 degree alcohol is converting into ketone. So the first thing you need to remember that to produce, to convert alcohol into ketone, you need to take secondary alcohol, right? So that's how you can take any, secondary alcohol and can produce respective, ketone. Now I have to take some other example. Now I have to take about, talk about tertiary, alcohol. So I tell you what, let's take the tertiary one. This is a tertiary one. I hope you understand. So a tertiary alcohol, first thing, do not undergo oxidation under normal condition. So it also requires, strong oxidizing agent, and elevated temperature. Why? Because the tertiary carbon is more stable, and that's why it has to have some strong oxidizing agent. And then another thing is that tertiary alcohol, do not directly convert into aldehyde or ketone. It breaks into, some smaller carboxylic acid. And what that carboxylic acid may be, these carbon, you need to understand that they converts into smaller. So what that smaller may be, this will be like, this may be one of the carboxylic acid coming out, right? And this will also be, coming out as RCOH, So this will produce a number of, let me write, it produces a number of carboxylic acid by involving bond between carbon and carbon. Should I write like that? Carbon, and produce carboxylic acid with a small number of carbon, right? So this is what the very important part is here. I tell you what, if you take tertiary, alcohol, the first thing you have to be very careful is that the condition required is aggressive. What aggressive mean here? Strong oxidizing agent is required and very high temperature is required, because a tertiary one is more stable. So in order to break the bond, you have to provide more energy. And then another very different thing is that it does not directly convert into aldehyde or carboxylic acid. It converts into carboxylic acid with less number of carbon as compared to the parent alcohol. So there are not just one. This will be producing this looks like 2 carbon of carboxylic acid. There may be some 1 carbon carboxylic acid and all. I will take you some example if possible there, and then so this is what the primary, secondary and tertiary alcohol can convert and produce you carboxylic acid or aldehyde and maybe ketone, right? And another thing that can also be used as a oxidizing agent to convert into aldehyde is that if you use an alcohol and you react it with copper, or you just pass it over copper, so this also converts into aldehyde. So there copper is acting as a something like oxidizing agent. Acting as a oxidizing agent here, right? And similarly, if you use a secondary alcohol, and use copper again, you just have to pass it through copper, then this will convert into ketone. Right? Another very important thing is that when you use a tertiary alcohol like this one, there is something very important, and you pass it through the copper, copper tube, heated copper and something. Now what important it is here, that if you use tertiary alcohol and pass it over the copper, this does not convert into carboxylic acid or aldehyde. Why? Because it converts into alkene. This converts into alkene. So what is that alkene here? This is what the alkene is. And apart from that, water will also be produced, probably, because that's a byproduct. Forget, because this might confuse you. So I was saying, if a tertiary alcohol is oxidized in presence of copper, or you pass tertiary alcohol over the copper, this converts into alkene. Now what this is called? This is called, substitution. This is called substitution substitution is competed, let me change it. Elimination competes over substitution. This is a very important line. I hope you have to, you probably know that. In case you don't, you have to remember that when elimination, is dominating over substitution, this tertiary alcohol will not convert into, aldehyde or ketone. Instead of that, it converts into alkene, right? So what is happening here? A 3-degree alcohol is converting into alkene when passed over copper. So that's what the oxidation part was. I hope you have understand every bit of that, because these are very important reaction in your NCERT, in your book, and that's going to be as a part of your paper. I have seen it. There are numerous example where I have seen this equation as it is in their pristine form, and you forget about because there's so many questions, you definitely need to focus again. But what I'm trying to do, I'm just trying to let you through a story where the story, the purpose to narrate this story is to make you go through very simple and very easy. So that's how the oxidation of alcohol takes place and gives a number of compound including aldehyde, ketones and carboxylic acid. But there is another condition where in presence of copper the tertiary alcohol converts into alkene because elimination takes place. So elimination competes over substitution. What that mean? Elimination is dominating over the substitution. So whenever elimination takes place, alkene is formed, but whenever substitution takes place, definitely that aldehyde, ketone and carboxylic acid is produced, right? So that's how the reaction and oxidation part has come to an end. I would say thanks for watching. If this was really good or bad or whatever you have to say, do let me know. I'm desperate. I feel like, there are less of comment, less of, people expressing themselves how they were actually. The last time I had, a comment which I remember that was related to my handwriting, but I liked it, because there's something I cannot change. I have a very natural handwriting, maybe not that good looking or not that fast enough, I talk very fast, but I write very slow, right? Anyway, thanks for watching. Take care and, be energetic, and a very important thing, don't lose your hope. If there is a moment when you feel that you are losing your hope, get it back, right? Think positive. Look the things around you, look the people around you, and then I believe you will be getting the power you need, right? That's inspire people to work on. Thanks for watching.